Good morning, everybody. This is Mr. Raincourt. Before we start this paper right here, because this is the one you're going to do first, I just want to quickly review some terms with you that will help today's lesson. Okay? So set this off to the side real quick and actually pull these vocabularies out. And I'm going to put a star by these, and I want you to put a star by these so that you know that these are the ones I need you to focus on remembering for today. Atom, proton, neutron, electron, okay, nucleus, okay, and then on your next page, solid, liquid, and gas. Let me get your sheet real quick. Solid, liquid, and gas. Oops, sorry, you can't see that. Okay, so stars by those, I believe that's 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. All right. So real quick, just a real quick review. The atom is the basic unit of all matter. So when we break stuff down into its most simplest form, we don't get cells because cells are only living things, but we can break cells down into atoms. We can also break non-living things like rocks, like dirt, assuming that has no dead organisms in it. We can break all that stuff down into what we call these tiny particles. And you'll hear this term used as well, atoms, okay? And inside the atom is this center area called the nucleus, very similar to what you are, or what you've been taught when it comes to plant animal cells. There's the nucleus, okay? And the nucleus holds the protons and the neutrons. And all I just need you to know is that a proton is what I call a subatomic particle. So in other words, it's a piece of the atom that is smaller than the atom. Okay, it has a positive charge, and again, it's found in the nucleus. And what I really want you to understand is this, is that the protons determine the atom's identity. And what that means is this. So if I told you that hydrogens, and you can write this down real quick off to the side around here, if hydrogen's atomic number, write this down, atomic number equals 1, then hydrogen has 1 proton. If hydrogen's atomic number, that's the pound sign, okay, or the hashtag, excuse me, you need to use your terms. If hydrogen's atomic number is 1, then hydrogen has 1 proton. And we can change this up for anything. Helium's atomic number is 2. So you know that helium, which would go by He, by the way, has 2 protons. And I can do that in reverse as well. Like I can ask you, if hydrogen has 1 proton, what's its atomic number? And you should be able to tell me it's 1. So those two things are interchangeable, okay? All right, next thing, electrons. So electron is the subatomic particle that has a negative charge, and it's found outside the nucleus. It's actually found in that thing called the electron cloud. And if I bring this paper over here real quick. So this would be the nucleus. This would be the electron cloud. These entire things right here, yeah? And depending on what atom it is, there might be more than one ring. And that we'll talk about a little bit more about that later, okay? But this is the electron cloud. These are the electrons, okay? All right, and the reason why I saved this one last is because there's a reason for that. So the neutrons are in the same spot as the protons. They're inside the nucleus. They share that house together, so to speak, yes? They're found in the nucleus, okay? And what I want you to understand also is this. Actually, I'm gonna hold off on that thought. I think that's probably a little too much information. I just was in the thought, I was gonna share some new information, but I think I'll wait on that one, okay? So we have atom, proton, neutron, electron, and nucleus, okay? Last three, solid, liquid, and gas. When I'm talking about what state of matter something is, I'm talking about, I want to know if it's a solid, liquid, or a gas. So solids are a specific type of matter. They hold a definite shape. This has a definite shape, yeah? The atoms are packed together tightly. So if I were to put this underneath the microscope, yeah, or anything that's a solid underneath the microscope, I could see that the atoms are crammed together, yeah? They're condensed, okay? and they're packed tight, more tighter than that of a liquid or a gas. Okay, and if I asked you that on a test, which one has atoms that are packed the closest together, you would tell me a solid. Okay, and that just makes sense because solids are harder than liquids and gases. That's how I remember it. Liquids, they take the shape of their container. And I'm out of my water. Darn it, I am. So just imagine I have a water bottle here, yeah, and I'm swishing it around. The liquid inside takes the shape of the container, and its atoms are less dense than that of a solid, meaning that the atoms can spread out. Well, that makes sense because you want, or you can see that liquids spread out in a container. They fill the container, assuming that you fill the container all the way. So they're less dense than a solid, but they're more dense than a gas. A gas. It's a type of matter. It also takes the shape of its container. It has definite volume. That's what that means. And again, I told you that if you were to fill up a balloon, the air would take up the shape of the balloon inside. That's how you know that the gas, or the air, excuse me, has volume. And it's the least dense. And it's the least dense because the atoms in there spread out really, really far apart. Okay? So in a solid, they're packed tightly together, the atoms are. In a liquid, they spread out a little bit so that they can slide. I don't know if they're not. Maybe this would be better. They can slide in and out of each other, past each other. They can flow freely, yeah. And then in a gas, they spread out even farther, yeah. Super, super far apart. Okay. All right. So that's enough review on that. All right. So just to hit home what we talked about in the last one, I gave you this. When you're done with this, you're actually going to glue this into the next page of your notebook. But I want you to fill this part out real quick. Yes? Tell me the charge of an electron. Tell me the charge of a proton. Tell me the charge of a neutron. Yes? I'm not going to do this on this video. You're going to do this. Okay? I also want you to fill in this part right here. The nucleus made up of blank and neutrons. Yeah, we literally just talked about this. If you don't remember, rewind this video. Okay? The one thing that I really want you to make sure that you understand is that atoms have the same number of protons and electrons. Okay? So wait, that means this. Go back to this page real quick. I told you that if hydrogen's atomic number is 1, then it has 1 proton. Well, then it also has 1 electron as well. So just by knowing hydrogen's atomic number, we know several things about it. We know that it has 1 proton. We know that it has 1 electron. Yeah. We obviously know that its atomic number is 1. Yeah. We also know it's going to be the first element on the periodic table. So if you look at the periodic table of elements that's posted on my board in the upper left hand corner, you'll see hydrogen's in green, and we'll talk about why it's that green one is all by itself next to the orange later. But you can see that hydrogen's atomic number is 1. It has 1 proton. It also has 1 electron. Cool? I need you to know that. Circle that. Circle that. And when you come up to show me this in just a minute, after you fill this in, I want that circled so that you remember that. Okay? All right. This I'm going to help you with because you won't know this real quick. All right? So here's what I want you to understand. So lithium's atomic number is 3, and I just want you to write that right here. Okay? You can see that it has 3 protons here. You can see that it has 3 electrons. Excuse me, I lost my train of thought for a second. And then count the blank circles for me real quick. 1, 2, 3, 4. It has 4. So your question might be, well, how do I determine the number of neutrons? Well, you need a little bit more information, and this is where I kind of wanted to tell you the information before. Now I'm going to tell you now. In order to determine the number of neutrons, you actually have to know its atomic number, or excuse me, its atomic mass. So its atomic number is 3, yes. On the bottom of this square, excuse me, on the periodic table, it's also going to have another number. It's going to have, and for lithium, it's 7. It's 7. So the atomic number AN will be on top. The atomic mass will be on the bottom. There's two numbers now you have to know, or be able to find, I should say. Now I want to give you just a second to figure out where we get this 4 from. I told you that lithium has 4 neutrons, yes. I told you that its atomic mass is 7, and I told you its atomic number is 3. So think about it real quick. And if you said to yourself, well, I just subtract the bottom number minus the top number, you're absolutely correct. So to find the number of neutrons, you're going to take the bottom number minus the top number, or the atomic mass minus the atomic number. Okay? And when you come up, I'm going to ask you this too. I'm going to ask you to explain, how do I find the number of neutrons? Okay? But before you do that, so you're going to fill in all of this. You should have already this filled in. I also want you to color code it, and I'll put the I will put the colored pencils out. I just have markers, so I'm going to use markers for a moment. But I want you to first color code the protons, neutrons, electrons. Yes? Okay? So I'm going to use blue for protons. Got it? Don't color code it in over here, because then you'll cover up the symbol, and I need you to remember that. But I'm just going to go through here real quick, and I'm just going to shade in all my protons the same color. Careful, don't go into the blank circles. That's why I want you to use a colored pencil. Okay. So choose any color. It doesn't matter what color. Okay. The color and the protons, whatever color you chose up here. And do the same for neutrons and electrons. And I'm just going to use pink real quick because I think it'll show up a little bit better. My neutrons are in the center of the nucleus. Cool. I should have 4. Here. And this is not the same as that, obviously, because you can tell this has more electrons and protons than neutrons. And in just a second, I'll look this one up. I'm not really counting it at the moment, so I can't tell you which one it is. I'm just coloring. And let's do electrons real quick. Let's do green. Now I'm going to count 1, 2, 3, 4, 5, 6. Oh, it has 6 electrons. Well, then it should have 6 protons. Let's count it. 1, 2, 3, 4, 5, 6. It does. And just so you know, this is carbon. And I want you to write that here. Carbon has 6 electrons. It has 6 protons. Yes. And its atomic number is 6 also. Okay? All right. So again, fill this in on your own. Yes. Have that circled. You should have all this written down. Be ready to tell me how to calculate the number of neutrons. And if you're not, make sure you come up and say, I don't remember how to do that. Can you explain that to me? I will do that. Absolutely. Make sure you have this color coded. Don't color in the nucleus because you can't really color in the nucleus. Oh, I missed a circle here. My bad. All right. Hope that helps. Thanks. See ya.